Here are the notes for thermodynamics part 2. We have an equation that we're going to be using. So we have the equation Q is equal to mc delta T. Q is for heat, and it's anything with a J next to it. It's going to stand for Q. M is for mass, so anything that says G has a mass. C is for anything that has J over G over C, and delta T is for anything that has degrees Celsius next to it. If you see a Kelvin, then you must change it to Celsius. So here are some definitions here, and of course, you could read them on your own time. And here we have, for question number 1, it says a pile of lava was poured onto water at 23 degrees Celsius. The water rose in temperature to 89 degrees Celsius. The water weighed 1.2 kilograms. Calculate the heat transfer between the lava and the water. So this has a C next to it, and as we already know, if it has a C, it means it is temperature. And this has a C next to it, so it is also temperature. Since we have two temperatures, we have to figure out which one's the one that we started with. So the one that we started with is this one because it says the water was initially at 23 and then it rose to 89. So this is our final temperature. The water weighed, so this is our mass, because kilograms is just a gram, what with a K in front of it. And then it says to calculate the heat, so we are looking for Q. So Q is a question mark. So what we're going to do is we're going to plug in everything into our equation. Q is equal to mc delta T. The mass is 1.2 kilograms, so we have to change that into grams by multiplying by 1,000. And we get 1,200. The delta T is going to be equal to final temperature minus initial temperature. The final temperature was 89. The initial temperature was 23. So 89 minus 23 is 66. So delta T is 66. And then the last thing is the C. C because it's going to be 4.18. The reason it's 4.18 is because we are talking about water. And water has a specific heat capacity of 4.18. So if we look at this chart over here, the specific heat of water is 4.18, so that is why this has to be 4.18. So now we have everything we need. We have 66, we have 4.18, and we have 1,200. Let's plug in all these numbers into the equation. So the equation is right here. M is 1,200. We don't know Q, that's the one we're looking for, so we're just going to put Q again. C is 4.18. And delta T is 66. So then we're just going to put all that into the calculator using menu 3.1 to find our answer. So the answer turns out to be 331,056. Because it's Q, the unit is J, so we're going to put that as our answer for number 1. Next is question number 2. It says, a cupcake was burned to measure calories. The cupcake changed the temperature of the water from 25 to 38. So right away, we know that this is our initial temperature, and this is our final temperature. The water weighed 190 grams, so this is our mass. Measure the calories, energy as heat from the cupcake. So we are looking for Q. So we know that the M is 190, so we're going to put that here. Delta T is final temperature minus initial temperature. So it's 38 minus 25, which is equal to 13. And then C, because this is water that we're talking about, it's 4.18, according to the chart that I gave you. So then we are going to plug in everything into the equation to find Q. Q is the one we don't know. It is a question mark, so we're just going to leave it as Q. M is 190. C is 4.18. Delta T is 13. So Q is going to equal to 10,324. Make sure you put a J as your unit for your answer. Next we have question 3. It says calculate the energy usage of a hot tub from if the water was heated from 20 to 33 degrees Celsius. The water in the tub weighed 70 kilograms. So this is our initial temperature because that's where the water started with, and this is our final temperature because that's where the water ended up. And we know that this is our mass because kilograms is mass. But we have to change that 70 kilograms into grams. So 70 times 1,000 equals 70,000. Delta T is final minus initial. Your final temperature is 33. Your initial temperature is 20. So your delta T is 13. And your C is 4.18 because again, this is water. So next, you're going to plug in the stuff you know into the equation. So M is 70,000, C is 4.18, and delta T is 13. And the answer will come out to be 3.8 times 10 to the 6. So we're going to put 3.8 times 10 to the 6 power with a joules next to it. So that is question number 3. Next, we're going to move on to question number 4. It says a steel plate of 1.4 kilograms was left outside. So we know that this is our mass. So M is 1.4, but it's kilograms, so we have to multiply that by 1,000. Where it was cooled from 25 degrees Celsius to 3 degrees Celsius. So this is our initial temperature, and this is our final temperature. Calculate the energy lost to the surroundings. So our delta T is going to be 3 minus 25. And we get negative 22. So the delta T is negative 22. The M is 1,400. Next, we have to figure out the C. This is steel that we're talking about. Steel has a specific heat of 0.466. So this is the one that we're going to be using. So let's plug that in here. And now that we have everything we need, we could plug it in to our equation. So it's going to come out as negative 14,352.8. So that is going to be our answer. So here is number 5. It is going to be negative 36,575. And this is the work that is required to get there. Questions 6 through 9 are going to be about finding C, and this is a little bit more challenging, and we'll do that in the next video.